Okay. All right. We are live. How is everyone doing? Welcome to live dashboards, boosting app performance with real-time integration. So I'm pretty sure that most of you probably have built applications that basically use a relational database, and your application may have a lot of traffic. There may be a lot of requests, a lot of on your website. Your web application may have a lot of requests, and you may encounter some delays. You may encounter the website not being as responsive as you like it, maybe because due to the database, maybe the database is not is being overpowered by a lot of requests, a lot of reads, and a lot of writes concurrently. So we all seen some of this behavior in our applications, and we think about ways of improving the performance and improving the way the application behaves, right? So if that's the case, and if you're wondering what are the type of approach that you can take to do this, well, this presentation is going to help us talk about that and go over in a scenario where we actually build a web application using Angular, Node.js, and we're actually using in the backend a SQL Server database. And we're going to go step by steps to see the use case, see what's going on, and see how we can improve it. So welcome to this presentation. My name is Oscar Garcia. And basically, I'm a software engineer. I focus on architecture using building web applications and data platform using cloud technologies. I love building applications. That's what I do for a living, and I love to share my experiences and things that I see that can help many of us as I learn and I come across projects where I see some businesses struggling with some of the integration. I'm also an author. I wrote a book called Data Engineering Process Fundamentals that not only looks at a data engineering in the sense of technology, like just choosing technology, but I go towards using a process-oriented approach where we talk about the different phases of the data engineering project, which also is applicable to web engineering, building web applications, but the concepts is really the approach, the process, the methodology to be able to put that process in place. If you're really interested, you can just scan that that code right there, scan it with your phones. That will take you to a page where you can actually have links towards the book. If you're interested in reading some about it, you can download a free ebook version of it with the sample chapters. And you can also have access to some of these GitHub projects for you to actually look at the code. So I actually, if you look at the chat, I actually put a link to the GitHub project that we're going to be working on today. So you are more than welcome to use it. All right. All right. So let's start with the story, right? So let's talk about this story here, telemetry data story. What are we really talking about today, right? So as an example here, what you see here is really a live dashboard, right? And what's happening here is that you see live data streaming into this application. This is an Angular application, so it's actually loaded on a web browser, right? So and the way this works is that initially we have a web application and we have devices, right? So in the manufacturing world, there are devices that are actually streaming data to some backend, right? To a SQL backend, our data warehouse, a data lake, and so on, right? So they send this telemetry data via an API integration to a database, right? And this is massive amounts of data, right? So this is hundreds of devices sending data, telemetry data per second, hundreds of data points per second. So this creates a lot of performance problems with the SQL backend, right? Because SQL by nature is a disk-based database. What that means is really storing some of this data, and when we need to read this data, we need to do reads. And when this telemetry data is coming into the database, there's a lot of writes. And if you're familiar with the way SQL databases work, is that you basically are locking some of the pages within the database, and this creates contention as you're writing a lot of records, right? So what we want to be able to do is sort of understand this problems, these challenges, and progressively enhance the system in such a way that we don't overwrite the entire system. So basically, usually, everybody talks about let's rewrite the whole thing. And the intent here is to just show you an approach where we can actually take a look at an application and write it using certain design patterns to be able to just attack it and not impact the entire system. So for example, by using design patterns, we can probably just change the repository services and the communication services to be able to change from an API approach to maybe a real-time integration approach, right? Without having to change a lot of the front-end code, right? So the idea is here to create it, develop the application in such a way that we don't impact the UI, and there's only the communications, the way that we integrate with systems that's going to be built in such a way that we can, the UI will be agnostic to what's behind the scenes, right? The UI will behave the same as long as we maintain the same communication protocols and the same data format or the models that the telemetry information is sending to us. So for us to clearly understand how this works, right, let's first start with the database integration, right? Typical application that we use, right? We build applications, whether it's a web-based app or mobile device or an IoT device, and this basically integrate with a SQL backend, right, which is a disk-based storage, and we call APIs to be able to query the database and get data, or we call the API to send data, like IoT devices may send the telemetry data via API, and they just send this data constantly and with a lot of IoT devices concurrently sending information at the same time, right? So we start thinking about this, right? This is kind of like maybe there's going to be a problem if we have a lot of traffic coming in through the APIs, right? As we try to read this data. So we want to take a look at this. We want to review our API integration and talk about how this is done. And then we want to take an approach that we don't have to rewrite everything, but we want to use WebSockets to be able to do a real-time integration. And we'll demo some of that stuff, how that works, right? Then we're going to try to take a look at this and say, hey, look, it's not enough to just use a real-time integration with sockets, because we still have the SQL backend as our core and fundamental data repository, and maybe that's really the focus of the problem, right? That this SQL database is being stressed too much, and how do we alleviate that stress, right? And so we talk about the strategies that we use to address that and centralize the real-time integration in such a way that our applications are disconnected from the backend. And we're also getting data in real time without doing a lot of I/O on the SQL backend. So how do we do that? All right. So let's, before we get too much into the detail, how do we solve this? Let's look at the problem first. So first, let's look at the RESTful API integration. This is basic core applications, right? How we do this. We start with REST API with the Node.js application. We do a type ORM, which is a library to be able to do data mapping, to create entity and model definitions. So we map to our database tables, right? We have an Angular client application, and we have a SQL backend, right? So the use case here is that we have an IoT device that's sending data, and we're reading from a backend, from a dashboard, and we're reading all this data that's coming in, and we're polling the database to get new records. And polling is really when we're actually sending a request to the database and say an API request to say, hey, give me the data, give me the data. And that's the project link is right there. I also added the link into the chat. So if you want to follow that, you are free to go and do that. But let's jump into the demo and just take a look at that. So quickly, if we go into the GitHub project, right? So what we're gonna see here is you have all the code here and that you can browse, and you can read some of the information here to be able to run the project and understand really what we're trying to do, and how you can run it on your desktop, how you can build all the different projects, and how you can install Redis also, and do all of this that we're going to be presenting today. So you have all the information here on how to run that. Okay, we're going to use Visual Studio to run the code, the demo, but here just want to give you a overview of what the project looks like, right? So here what you are going to find is a server folder and a client folder, and the server is really your server component. That's really your Node.js backend code, and the client is your Angular backend code, right? So if you're familiar with the way Angular works, you basically have modules and you have components and so on. So you can, as we drill into the project, you'll be able to see all that code there, right? So, but let's take a look at the application. How does this application work, right? How is it that this is behaving? All right, so if we take a look at this, right? So we have a dashboard, right? And we have this dashboard here is running, it's reading all this data. And we're gonna have also, so look at the port number. And this is also identifying the GitHub repo with instructions. So on port 4200, we're gonna be loading the dashboard. And we're gonna have a test application that's running on 133A, right? So we're gonna load this by starting the server. So the server component is running on port 133A. So we're gonna go ahead and do that. And we're gonna go ahead and go here to the code. And we're gonna run the server component and the client component, right? So and we're just using npm, right? And so npm really is just it's a JavaScript libraries to be able for us to build, run, execute our projects, right? So we're gonna be running the server component that's actually hosting the APIs, hosting the socket application, and we're gonna just go ahead and build this out. So let's just give it a minute as we go and start loading all these projects. So what you want to take a look at this, just like I said before, this is the same repo, and we're loading the server and the client component. So quickly, we're just gonna browse this really quick while this is building. And what you want to take a look at is this server file within the server folder, right? And what I'm gonna blow this up a little bit. So the server file here, what's really is a Node.js application. And what it's doing is really just adding, importing the libraries. And what you want to take a look here is how we are actually importing some of the modules that we need. So for example, we may need the API module to handle the API. We need the socket module to handle the sockets, and we're going to drill into them as we go. But, this is a basic Node.js server application that's just loading APIs and just hosting a page, right? So the way we start here is you want to take a look at line 72, right? So we start using a repository strategy here. And what does that mean, right? And we're going to take a look at that. So what that really means is that we're saying is to the front end application, we're just going to sort of inject a repository that's going to represent maybe a SQL backend, maybe a Redis backend, maybe a NoSQL backend, and so on, right? So it's going to be agnostic to the application. It just knows that there is some sort of a storage that we're going to be using, right? And then we're going to use the API modules to be able to say, hey, we need to initialize this API module, and we need to use this repository for this, right? So if you just look at the repository application, really what that just really is doing, it's just detecting, right? So it's really like a sort of a factory here that's saying, hey, if I need to have, if you look at the top, you will see, hey, if I need to have an in-process type or a SQL or a Redis or a broker, and we're going to get into the broker information a little bit deeper as we move forward, then you can actually go ahead and look at this. And we can see now that we set up our strategy here, right, in such a way that as we just call from the server, we say, hey, I want the SQL strategy, so go ahead and get that, right? So we're going to go here and say, create that repo, get the SQL strategy, send that back to us. And now we just use the API layer to be able to do that. And the API, you can definitely just go ahead and just take a look at what it does. And this is the API. So what it's going to be doing is just going to be defining the routes, right, to get and to post the telemetry data. And to be able to call as we inject the provider into it, then we just use the provider with the same signature, right? So we have a contract, we have interface definitions to give us the same contract, so that way we can inject any provider and be agnostic to the back end and be able to say, get this, or if you want to add the data, add this, right? And this is very fundamental and key to have this approach, because then easily we can flip that provider to something else and use a whole different system, right? A whole different system, the whole different backend without impacting some of the code. So that's how the server behaves. So now when it comes to the client, and this is more into Angular, if you're familiar with Angular, but this works for all other frameworks, right? Like React, Vue, but the concepts are basically the same, but the approach is that you're gonna build a module. Again, in the sense of Angular, we build a module, and that module is gonna have some components, right? And one thing that's important here, so we don't impact the UI too much, we wanna be able to inject that module with the corresponding services for it. So in this case, what we're saying is we're saying, hey, we're gonna provide this telemetry service, right? And we're gonna use the API type, right? So remember, we're looking at the client project now, not the server, right? So this is a whole different folder. So just to make sure that we understand, right? So we have a server folder and a client folder, right? So we're looking at the client code now, and we're saying, hey, inject this service, which is going to be an API, and create a service, right? And when this module is loaded, right, this telemetry module is loaded, it's going to go ahead and call the component, this telemetry component, right? And this telemetry component, basically what it's going to do is going to be able to handle the logic to build the dashboard, right? It's going to go ahead and use libraries like Plotly, which is a powerful UI library for building charts, right? So it's going to go ahead and just do that, and it's going to say, okay, so I want to build an observable, and the observable will be for our data stream. So, or in the case of an API, right, it's our data payload. If we flip this into a data stream, it will be a data stream in this case, but this is really, we're going to have an observable. So as events come in, we're going to be building out this charts, right? So here in the constructor is where we inject this telemetry service, and that way we're doing it here, right? And we're saying it's an API service. So we're going to go ahead and do this. We're going to subscribe to that observable, and we're going to say, hey, as data comes in, just build this charts, right? So that's basically how you would see this in the code, right? And then to look at the service, you basically can take a look at how we import the service here, right? And you can see that there's a telemetry factory here also on the client side. So there's a factory to be able to tell us what services to use. And those, we use them through when we inject them, we tell them what service type to use. In this case, we're saying API. All right, so that's how that's going to be injecting that service type, and it's going to be an API. So what we do now is, when we come here and we just run the application. So the client application runs on port 4200, right? So what it's going to do is going to go ahead and go to the database. It's going to make a request to the database and get that, right? So it's going to integrate with the server side, and it's going to call this. And it loads the dashboard as we saw it. So we call that telemetry component, right? We injected a service. The service went and did an API call. And we see that it's right there. It's loaded with some data points, and that's okay. So on port 1338, which is a server UI, so this is running on the server, right? So keep that in mind. We can go ahead and just integrate via API, right? And we can just add messages, right? And we can just add a message here and another message there. And if we switch back to the dashboard, of course, we don't see the messages, right? Because we need to have logic to refresh this, because the way this works is that it's using an API integration. It needs to call back that API and reload the data, right? So, so what we have to do here is we just got to reload this page, and as we go, it's going to go get more data points, right? So as you can see here, we keep reloading, and now we're getting new data points, right? And you see the dashboard is going. But of course, so we have full integration with the API, but we see what the problems are here, right? The problems is an API. We have to do like a meta tag to be able to say reload the page, or do some logic to reload the page via JavaScript, and we keep polling the database. So we keep sending requests to say, go get data, go get data. Ideally, this causes a lot of problems. And ideally, you want to be able to address those problems and have the data coming to you, because the way this works, especially in the manufacturing world, is that there's so many data points that you need to monitor this in real time. You want this data to come towards you, to come into the UI and be able to see what is happening. Okay, so how do we do that? Okay, so we saw that we have this RESTful integration here, API integration, but then we have problems with that, right? So what are those problems, right? First of all, because there's so much traffic going into the database, there are issues. There's optimization issues with the database, right? And we want to address them. We know we can have slow queries. We need to be able to maybe improve our indexing in the database. We need to do partition strategies. And we need to improve the way we query the database, right? So we start working in many projects to improve the way to access the database, to eliminate contention, to simplify the data access, right? So we may denormalize the database because, there maybe has two joins. In this case, it's a simple table, but the point is that we go through a series of approach to be able to improve the database performance, right? To address database contention, right? Because when you have a system that has a lot of inserts, a lot of writes, a lot of IO, then the reads are actually blocked, even though you may do query hints to try to prevent the isolation level from blocking. But once the system is overloaded, you're going to have that. And you have the cost to scale too. So you start doing replications, you start indexing and doing all kinds of strategies to optimize the database, that you start spending a lot of money. And ultimately, you want to go into a data lake and data warehouse implementation, because it's a lot more powerful, and you're going to have a lot of parallelism performance, so a lot much better performance. But in reality, it won't address the fact that some of the systems have a requirement, which is I want to see the data in real time and I don't want to pull, right? So even though you may end up with the data warehouse at the end, you still need to have the real-time integration. So how do we get to that? So the real-time integration really is done by using the concept of WebSockets, right? And this basically what it is a live connection, right, to a using a bidirectional channel with the server. What that means is it's a live connection as opposed to the postbacks, right? The postbacks are disconnected. You just send a request, you get back a response, and that's it. It's sort of disconnected. This is live, and that way you're streaming data in such a way that you can actually get the events sent to you as you do the work, right? And that's what's called data streaming. You'll hear that about data streaming. So in this case, you can use things like Socket.io for if you're using JavaScript, TypeScript, or you can use SignalR if you're using .NET, right? But the whole concept, what the technology underneath it all is with the web sockets, right? And underneath that, there is something called TCP sockets, which is really the low-level implementation of communication through the TCP layers. Right. So the use case here is that we notice that we don't want to be refreshing our page. So we don't want to be just reloading. We want to be able to use a socket implementation to address this, right? So how do we do that? All right. So we go back to the code, right? And we talked about we have this service types that we want to work with, right? So if you go back to the server now, what you want to be able to do is, instead of using a API layer, what we're gonna do is we're gonna go ahead and just do a socket implementation. So we're just gonna we're gonna initialize the socket, and we're gonna use the repo layer also, the same layer, and to be able to now do a socket integration. So at this point, what's gonna happen, the server is gonna start on the same port to listen on a socket channel, right? So it's going to be just listening to this, waiting for somebody to connect. And on the client side, what you want to do is you just want to remove the service type, and you just want to use the socket service type. So you can just do that by going to definition, and you will see the type of services, API and socket, right? So what we're going to do is we're going to do socket here, and we're going to save this, and And we're gonna restart this because my live reload is not working properly. So we're just gonna go ahead and restart it. Okay. So, all right. So the server is reloaded. The client did not reload, but we're starting it manually, so that's okay. We're saying we're gonna use the socket integration. So what does that look like? So what that is, while that's compiling, let's take a look at that. So we go take a look at the socket library here, and we importing the socket IO framework to do this. And what we're saying here is we're saying, hey, we're gonna configure this socket server here to listen on a particular port and to actually whitelist some other IPs, right? So because you remember, if you have ports and you need to whitelist some of the remote servers to be able to allow them to communicate with you. So that's basically the standard way to set up a server component here, or a server application. And we're saying, hey, we want to define some events. We want to define like the onConnect event, onCreate, onAdd. And these are events to be able to know that there's a client connected, there is a new record being added, and so on, right? So this is more an event-driven type approach now. So what we do is we go and initialize the socket connection, right? And then we start listening on connection, socket is ready. And you can see at the bottom here, a message came in, socket is ready. So someone connected to it, right? Some application connected to it. And that's probably our test harness that we have on the other side of the screen that you will see. We'll flip to that later as we just finish talking about this. So here's how we get the, hey, we got an odd message, on create message, and so on. So we start looking and receiving events that, hey, a new record was created. This can allow us to now stream that record back to the clients that are connected via socket, and then the dashboards can refresh, right? So you can read the rest of the details here. It's all in the GitHub repo. But the idea is now that we're in the server, we integrated a socket layer to be able to listen. On the client, we change our connection type to socket service, and we can create, and we can go ahead and look at the services that are available here, right? And we look at the factory here, and same approach. We're saying, hey, if this is a type API, we look at the telemetry service on the client side, remember, and now we're just going to look at the socket service on the client side, right? So with this factory now, we can actually minimize the impact of the UI and say, hey, I want to inject this service now, right? And the socket service just works basically the same. It has the same interface definition. So we're using TypeScript to be able to leverage that. And we're defining the same contract, right? So that way our factory can work, and our client can also understand that has a set of methods that it can rely on and use them without breaking anything, right? So it's the same thing here. We create an observable, and we're able to listen to the things are coming in, right? So we set up our properties, and now instead of just being an API connection, we actually do a socket IO connection, and we're able to get to receive messages, right? So this is the entire configuration how we do that, right? So we set up our connection, we listen on it, we listen on created messages, same as the server, and we start having a way to say, as event comes in, listen to it, right? And append the data to my storage, right? Which is really a strategy to do a sort of a caching, local caching storage, to be able to refresh the dashboards faster, right? So this is the entire socket service implementation. You can take a look at that and see how we disconnect, we update the storage, and do all these strategies behind the scenes to abstract the whole thing away from the UI. So the way that works, how that looks now is that when we go to the client application, of course, we reload this because we rebuilt it. And in this case now, it's the same app, nothing really changed, but now we're gonna use our test harness, and instead of using an API, we're gonna use a socket connection, right? And then let's see if the socket connection is live. Let's see. All right, so now we connected, and a bunch of events came in, because the way this works is that when you initialize the socket and a new client gets connected, all of a sudden there is a cache of data that is sent to the client, and it receives this data in real time. So there is some data available all the time. But where the magic is that now if I were to start sending real-time messages, and I'm sending these messages across, you see this being sent there. So this test harness is actually sending messages to the server, and the server is saying, okay, so anybody that's connected to this channel is getting these messages as well. So if you look at the dashboard now, you can see how the dashboard is moving in real time. So data points are coming in and reloading some of this information. Our scorecards are changing. If there is a higher max temperature coming in, same for the max sound and the max humidity data points. And this dashboard is just live now, getting this data as we basically, as the data is coming in, right? So this is really the power of the real-time data integration, which you can see from here. And you also, you can see from the server side. We're going to stop this real-time integration, but you can see from the data server side logs, you can see how the messages were being initialized and sent, right? So this is really how you do it. So we're able to change this from an API to a socket application, but we still have an underlying problem here. So the biggest problem we really have is, even though we sort of met the requirement to do this integration in real time, we're still using a SQL repo. We're still just depending on a SQL repository, and we're just really sending a lot of traffic across. And whenever our sockets are connecting, we're still query the SQL backend, and we're still having those data contention issues and all that. We alleviated some of the problems by having a real-time integration, right? It's preventing APIs, requests all over the place, and actually now having the UI a little bit more responsive. But we still can be very aggressive on the SQL backend and slow it down. So for that, what is it that we could do to fix that, right? Let's take a look at that. All right, so we have this real-time integration, but ideally what we want is we want a distributed data cache, right? So we want to be able, hi, by the way, I forgot to turn on my camera, but this is me. A distributed cache strategy, right? So, and what is it? What is this? If you remember, we presented this using an integration without a cache and just going into the SQL layers directly. Now, so how do we address this, right? Let's talk about a cache, right? So we use a cache to store data in memory, which eliminates I/O, right? So SQL backends have a high I/O because they got to write to disk. They got to commit to disk. A cache, a distributed cache, is all in memory. Of course, there are some problems with that being in memory, but there are strategies to refresh and recover the information in memory. But the access is fast. To be able to write and read from the cache, because it's in memory, is super fast, right? So you can see that it's sub-millisecond average speed. So that really will be lightning fast. And we can implement patterns to be able to support our legacy system with our SQL backend and integrate a new caching strategy behind the scene, right? So we can use something like called cache aside pattern, which really what it does, it really is a way for applications to read the cache first and fail over to the database if there is a cache miss. And when it fails over to the database, it will get data and it will replenish the cache. So it will actually maintain that cache with data always. But at least the initial hit may just be one-time SQL backend access. But then once the cache is refreshed, you're not going to see the SQL, and the cache will be updated in real time. And then we're using the write-through pattern as well, where we write to the cache and the database to maintain both of them in sync, right? So we maintain those two systems updated, so we know there's guarantee that the same data is arriving in both places. The whole goal is to improve the app performance, reduce completely the load on the database. So how do we do that, right? How do we do that? So let's talk about that. So for this, we can use Redis, right? We can use a combination of Redis and a socket application to do this, right? So with Redis, and what is Redis, by the way? So Redis is a key value store, right? It can contain strings strings, JSON documents, hashes, lists, and so on, right? So you can package your data the way you want, and you can write it to Redis, right? It supports transaction. It supports publishing and subscriptions. It has a limited time to live, which that means is if you don't want that data forever, like in the case of telemetry data, we don't want that data forever. We just want that data. What's important there, the window is maybe 10 minutes, right? Maybe 20 minutes at the most. They don't care about looking at data from 3 hours ago because it's a real time requirement of looking at the data that's happening now. If something is going wrong, they want to be able to stop some of these devices from continue to run because there are failures all over the place. So the use case really is that we as the application increases, right, is increasing, there is more traffic, there's more load, then we need to incorporate a cache into the system. And imagine also another of the problems that we did not see. We didn't, if you pay attention, you will notice that a socket server may be low balance, right? And when a client application connects to a socket server, it has affinity to that connection. What that means is that, let's say there's 3 socket server applications. A client will connect and have affinity to maybe server 1, for example. And as data come in, the data may come in not on server 1, but server 2 or server 3. So how does server 1 notices or understands that a new data comes in? So we have to have a publish and subscribe mechanism at the enterprise level where all the socket servers are updated, right? So that way, all the clients that are connected to different servers and they have affinity to their own servers, they will get the same communication across the enterprise. So by looking at our code, we kind of start thinking, how do we support this? How do we make changes and we don't start rewriting the entire system? You know, what is the strategy for us to do here? So what we want to be able to do is incorporate this new Redis system, integrate it within our flow, and not impact our application. So how do we do that? A few things you will notice here is just learn a little bit of the commands from Redis. We're going to use the Redis CLI to be able to start some of this integration with Redis. And we're going to be and you will see some of the commands here on this slide, but pay attention to that one. That's the read, subscribe, telemetry data, right? So telemetry column data is a channel. It's a channel name that we define as we did this integration. But just pay attention to that. So as we do the demo, you will see. Excuse me. All right. So how do we do this? Okay, let's take a look at the code now and go back. So we use this strategy here, right? So we have the socket implementation, we have an API implementation, but now we're saying let's use this broker strategy. What is this broker strategy? Let's take a look at that. Let's comment this out. Let's comment this repo up because we're gonna use a broker strategy. So here we're just gonna say we're gonna create a repo type broker, and we're gonna initialize the socket layer as well because we want both Redis support with the broker and real-time integration. So we're gonna save this, and we're gonna restart. It's gonna initialize a new broker strategy and be able to use that. And we'll take a look at that. When it comes to the client is the same. We're not changing anything. We're still gonna talk to the server via socket implementation. So our client remains the same. Okay. So on the server, we started. So let's take a look at this broker strategy. What is it? What does it do? So if you notice, when we get the broker strategy, what we're saying here is that we're gonna initialize this repository with both the SQL and the Redis strategies, right? So our broker, really what it is a strategy to be able to say, I'm going to handle both of these backend systems and be able to do this cache aside pattern and write through patterns to be able to say, I'm going to read from the cache or SQL if there is no data and so on, right? So it actually does this kind of work where it's actually doing all this entire work, right? So what happens here now, as we run this, the client is going to start listening to all these communications, and we're going to start sending messages here to make sure that all this is working fine. So let's take a look at how this is going to work, right? So what's going to happen now here is the client is still the same, no changes. But now we can go ahead and start saying, okay, let's just go back to socket and run in real time, right? And what it's doing now is just sending messages across again, right? Excuse me. It's going to start sending messages. Just got to make sure. Let me see if there are anything here. Okay, so it says app crash. What happens here? Let's see. Okay, so it says not found. So it looks like what it did here is, for some reason, our database was not connected. Let's take a look at that really quick. So, all right, so let's see. We just got a few minutes. Okay, so let's go ahead and just stop this really quick. Restart it. So when you see this error here, what that means is our database is not up. So it looks like we may have our database servers may have just terminated. So let's see. Let's see. I don't want to run out of time, but if you have any questions in the meantime, you can go ahead and do that. Okay, so let's see. Make sure that our SQL backend is running. Okay. Right. So yep. So we're gonna restart. Our SQL backend is fine. Okay, and we're gonna restart this. So it's listening. Socket is ready. Okay, we're good to go. This is listening. Our application is running fine. It's connecting. A broker is actually handling the request, and we see another coming in, or that was the old one. Okay, that looks like to be okay. So let's see. So what we want to be able to do now is we want to be able, okay, so that's what it was. So it started sending messages across, and you see that it's actually handling those messages. So we're back on, right? We're back to the same thing. Nothing has changed. It's all the same. The only difference now is that what you want to do here is once you go to the, we're going to do, hold on, let's just go use the terminal. So when we use the terminal here, sorry for the screen swapping, but there's a lot of screens here we got to deal with. You see the server is just handling a bunch of messages, right? And what we want to do here, okay. Oh man, my terminal. Okay, so here we want to be able to say, what I want to show you here is I'm going to just go ahead and run Redis CLI. And I know we're running out of time. In here, I'm going to say subscribe to the channel, which is telemetry data. And what we're doing here is really what we're saying is we're connecting now, not just a web application, I'm sorry, but we're connecting a CLI, right? We're connecting a terminal to this thing. And you see messages are also arriving. You see how on the CLI itself, the messages are coming in just like in the web application. So you see the server side on the terminal, messages coming in, and on the CLI, messages coming in. And you can see by the telemetry ID 3129, 3129, that this is actually synchronized. And you can tell now that our channel is up and a lot, is live, and it's just really sending data. And you can tap into it by just listening to that channel and getting that information. All right. So if you go with the real-time integration, you're going to boost performance. That's the bottom line, right? You're going to get real-time updates using WebSockets, and that way you listen to data, get events, and show the data points in your dashboards, right? This is going to scale massively, right? You're going to be reading from in-memory cache, and your data response is going to be quick, right? You're going to efficiently do resource utilization by not killing your backend, your SQL backend, right? But instead leveraging a real-time, a in-memory cache to be able to do the heavy lifting when it comes to data reads, right, for your dashboards and your applications and so on. So this definitely a lot of stuff we cover, guys. Go ahead and join that GitHub repo. Please give it a star. As you sign up on it, give it a star, follow it. You're welcome to propose changes, modifications to it. Just go ahead and fork the repo, make the changes you want, and submit them for PR, right? For a pull request. So anyways, I do want to thank everyone. Thank you for attending. Thank you for joining me today. I appreciate it. I'm going to be sending an email with the presentation materials and the video. We're going to post the video on YouTube. Please scan that code that you see there so you get more links to resources like the book and some of the repos, especially the data engineering. The data engineering repo is very popular. It definitely gives you a lot of coverage when it comes to data engineering projects using cloud technology and Python if you're interested in that. Okay, so thank you everyone for joining me. Thank you for your time, and looking forward to speaking to you again in a couple of weeks or so. Okay, so keep a watch on our projects, on our community for new presentations. Okay, thank you and have a wonderful night. If you do have any questions, you're more than welcome to ask questions if you have time. Thank you.